right, so here we have section 1, and will be section 2 as well for unit 1 in stats. So the first section is usually in any of these chapters kind of a review preview. It gives you a brief rundown of what you're looking at. So this one we've got describing, exploring, comparing data sets. We're looking at center, variation, distribution, outliers, and then changing characteristics of data over time. So the other important things we'll talk about are mean, median, variation. And then down below, we've got this lovely table, which you can't quite get all in at once, but this table has some data sets that we'll use later on. So section 2 is actually where the information begins. So up there we've got definition, just the measure of center as a value at the center or the middle of a data set. So mean is one of these, median is one of these as well. The first one we'll talk about is the mean. So we have the arithmetic mean, or the mean of a set of data is the measure of the center found by adding the data values and dividing the total by the number of data values. So this is the average that you're used to calculating. You add all the numbers up, you divide by how many numbers you have. Down below you've got some properties for the mean. So sample means drawn from the same population tend to vary less than other measures of center. So what that means is if I have a large population, say 100 or so people, and I take groups of 15 of them out and calculate the average for just those 15 people, the averages for those randomly selected groups of 15 should be relatively close to each other. They shouldn't skew very far greater or less than. So the second one there, the mean of a data set uses every data value, so you have to include every number. The third one there talks about the disadvantage of the mean. Means are affected by extreme values or outliers. So if you have one number that's very, very large compared to the group, or one number that's very, very small compared to the group, that will shift your mean up or down depending on which one of those outliers you have. What that means is that the mean is not very resistant to measures of center, because only one or two very large or very small values can greatly affect the overall thing. And down here at the bottom, we've got the formula for the mean. So the mean here, that's Greek letter sigma, it means add up, x, so all the values. N is the number of measurements you have, so the sum of all the data values divided by the number of the data values. Now there are two different ways we denote the mean. Depends on whether we're talking about a sample. So a sample, we use this symbol, x with a line over the top, it's pronounced x bar. So samples are small groups taken from a larger population. If you're talking about the entire population, you're using the Greek letter mu, which is a U with the tail on the front. Now, so for example, if I take my population to be all of the students in Warrensburg Latham High School, and I calculate the average height of a statistics student, take all the stats kids, and calculate the average height, that's going to give me an x bar, because it's a smaller group of the entire population. If I measure the height of every high school student here, that's my population, that would be the symbol mu. Okay, so here we go. We've got just some notations. So I talked about a couple of these before. So you've got, sigma denotes the sum of a set of values. X is the variable, it's the measurement itself. N is the number of data values in a sample, and capital N is the number of data values in the entire population. Then here are the two formulas. If you notice, the only difference is this one uses little n because it's talking about a sample. X bar is for a sample, mu is for the whole population, so it uses capital N. So table, or example 1 here, referring to the table at the beginning, find the mean of the first 5 counts for Chips Ahoy regular cookies. So to find the mean, we add all of our numbers up, and then we divide by however many numbers we have. So since this is a sample, this would be x bar. Let me just grab our handy dandy calculator, 22 plus 22 plus 26 plus 24 plus 23. So a number on top, got 117, and we divide by 5. So we get 23.4 on average chips per cookie. So the next measure of center we have is the median. So it's the middle value. When you order them, either increase least to greatest, increasing, or greatest to least, decreasing magnitude. So the thing about median is you have to have them sorted. Mean doesn't require it. So now the median is denoted by x with a tilde over the top. It's kind of hard to see, but it's the little squiggly guy, looks like that. So to find the median, you sort them and then follow the procedures. If you have an odd number of numbers, you just pick the one in the middle. If you have an even number of numbers, you take the middle two and average them. Find the mean of the middle two. So always be halfway between the two. So this is why you have to have them in order. Okay, so properties for the median. So the median does not change when you include outliers very much, as much as the mean. So it is a resistant measure that resists large or small values. And the median does not necessarily use every data value because you're not doing a calculation. So example 2 here, find the mean, example 1. So we've got these chips. So I need to put them in order. So 22, 22, so let's carry those two. Then the next biggest is 23, then 24, then 26. So that guy is the median. I have an odd number of numbers, so I just pick the middle one. All right, so this one here says repeat example 2 after including the count of 27. So you have these numbers. So you already have these 5 were our original numbers, and we're going to add in 27. So now I have an even number of numbers, so I need to average these two. So 23 plus 24 divided by 2. So that is 47 over 2, which is 23.5. So you see adding even a number here didn't shift the median by very much. So explore that. All right, so then the next one we have is the mode. This is one that occurs the most frequency, the most common value. So you have a couple definitions here. Bimodal refers to the fact that there are 2 different modes. Multimodal is more than 2, and then it is entirely possible that there is no mode, meaning each number only appears once. So example 4, find the mode of these values. So if you look at 22, 22, 26, 24, 23, the mode is 22. It's the only number that appears more than once. Okay, so next we've got the mid-range. So the mid-range is the number that's halfway between the maximum and minimum values. So here you see mid-range, you take the maximum data value, you add the minimum data value, and you divide by 2. So it's the midpoint, essentially, of your set. So because the mid-range only uses the maximum and the minimum values, it is very, very sensitive to the extremes, meaning it's very easy to affect the score by the outlier. So we normally don't use this a whole lot. The only reason you would is very easy to compute. Just as an example of another way to do this. And when we talk about, the other reason we actually talk about is to explain that this is not how you find the median. The mid-range, the number between the least and greatest, is not necessarily the number that's in the middle, because your most extreme minimum might be very, very, very small compared to the rest of them. So it'll give you a skewed result. So find the mid-range of these values. So we need the least and the greatest. So the least is 22. Doesn't matter how many times it appears, it's still the least. And the greatest is 26. So maximum data value is 26 plus the minimum data value of 22 divided in half. That's 48 over 2, which is 24. Now, since these numbers are pretty well grouped together, this is pretty close to the median. The median was 23.5, I believe, when we had all 5 numbers. Lastly, down here on this page, we've got round-off rules. So for mean, median, and mid-range, you usually carry 1 more decimal place than you would have if this shows up. Like here, these numbers have no decimal places, but there isn't one there. If you go back to the median, when I had 6 values, I carried 1 extra place. I carried the 10th place, even though my numbers only had whole numbers. The mode, since you're just picking from the list, there's no actual calculation involved. You choose the number without rounding. Okay, so here we go. Critical thinking question. Straighten up the papers. So example 6. So it says, well known that smaller classes are generally more effective. According to the National Center for Education Statistics, California has a mean of 20.9 students per teacher, and Alaska has a mean of 16.8 students per teacher. These values are based on only elementary and secondary, so no colleges. If we combine the 2 states, you might find the mean number of students to teach would be 18.85. So if you notice, they carry 1 extra decimal place compared to that, as the calculation shown below. But is this result correct? Why or why not? So this calculation, there's nothing wrong with the math there. This result is not correct. The reason is California has way more people. Than Alaska does. Or we call it students, I guess. Oops, capital A, Alaska's a state. So you can't average averages together. That doesn't give you an appropriate thing. Or people, students, or you could say classrooms, whatever you want. So in honesty, or in all actuality, I guess would be the best way to put it, the average should still be pretty close to California's, simply because California has way more people. So this is kind of like a weighted average, you might see. All right, so down below here, we've got a frequency distribution. So this is how you would calculate the average if you had like a histogram, where you didn't necessarily know the exact values, but you knew the categories into which they fell. So this is what's referred to as a frequency distribution. So you have your ranges over here, tells you how many values fall within that range, and then this part here, the class midpoint, is the middle of those two numbers. So if you add 50 and 69 and divide by 2, you get this value. So the midpoint is the middle value of these ranges. So when you're calculating the mean from a table like this or from a histogram, here's the formula for it. You multiply the midpoint by the number of times it appears, which is actually this column right here. That's the top of this fraction. Sum, actually this all the way down here. So f times x is each individual frequency times the midpoint. So for 50 to 69, it's 119 here. 2 times that number, 33 times that number, 35 times that number, so on and so forth. And then you divide by the total number of measurements you've made. So that's why we keep track over here. So I made 78 measurements. The total over here is 7,201. So to find the average, I would divide this value by 78, which is probably what the next question is going to ask us. So example 7 here, use that frequency distribution to find the mean. So x bar is equal to the sum of the frequency times the midpoint divided by the sums of the frequency. So from our table before, there we go. The top of this fraction was 7,201. The bottom is 78. So that goes in my calculator, 7,201 divided by 78. And I get 92.32, carrying one more decimal place than my measurements have. So that would be the average from that table. So according to my frequency distribution, the average IQ scores of a low lead group should be about 92. The last thing we have here, we're not going to get down to section 3 here, so ignore that guy for now, is calculating a weighted mean. So a weighted mean is similar to using a frequency distribution. It's just that each category has less effect than the other. So W instead of F, essentially. So in her first semester of college, student took 5 courses. Her final grades along with the credits for each course are A, B, C, and F. The grading system assigns quality points. So this is how a college calculates your GPA. It's how high school calculates your GPA. So an A is worth 4, B is worth 3, so on and so forth to compute her grade point average. So she had an A, a 3-credit A, so times the A value, plus a 4-credit A times the A value, plus a 3-credit course in which she earned a B, 3 credits B, plus a 3-credit course in which she earned a C, and plus a 1-credit course in which she earned a 0. So this is going to be, and then you would divide by the total number of credits attempted. So 1, 2, 3, so 3 plus 4 plus 3 plus 3 plus 1. So that's the W, the weight. Okay, the weight is the credits each course is worth. X is how much it's worth. So on top, we've got 12 plus 16 plus 9 plus 6 plus 0. 12, 16, 9, 6, 0. On the bottom, we've got 7, 10, 14. So working that top out, 12 plus 16 plus 9 plus 6 plus 0 gives me 43. Divided by 14 gives me, carrying 1 extra decimal place, 3.1 GPA, which according to our scale is slightly better than AB. So that brings us to the end of this section.